Here's the twist. Out of an entire array of numbers, only 2 of them actually matter. Everyone else in that array? Total bystanders. Once you see which 2, this easy problem becomes a one-liner. GCD questions show up in early round interviews at places like Amazon and Google because they test if you know your math tools. Under the hood, GCD logic runs inside cryptography, fraction simplification, and even scheduling systems that need to sync repeating events. It's small, but it's everywhere. You're handed an array like 2, 5, 6, 9, 10. Grab the smallest value, which is 2, and the largest, which is 10. Then find the biggest number that divides both evenly, and that's your answer. We only need 3 ideas here. Min and max are exactly what they sound like, the smallest and largest values in your list. GCD, greatest common divisor, is the biggest number that fits evenly into 2 other numbers, like how 6 and 9 both divide evenly by 3. So here's the trick. The problem statement basically hands you the answer shape. It explicitly says use the smallest and the largest, not all of them. That means this is really just the classic 2-number GCD problem wearing an array costume. You might wonder how GCD actually gets calculated fast. There's an ancient trick, Euclid's algorithm, where you keep replacing the bigger number with the remainder of dividing the 2 over and over. It shrinks incredibly fast. In short, you repeatedly mod down until nothing's left to divide, and that last non-zero number is your GCD. First, we pull out the smallest and largest values using Python's built-in min and max. I'm using the built-ins on purpose. They're implemented in C and already optimized. No reason to write my own scanning loop. Python's math module already ships a battle-tested GCD function, so we just call math.gcd on our 2 numbers. Honestly, brute force here would be looping down from the smaller number, checking every divisor. But why write that when the standard library already nailed it? In short, 1 import saves you 10 lines of manual math. Quick challenge for you. Pause the video for a second. What do you think find_GCD returns for the array 2? Lock in your answer before I show you. The answer is 2. When min and max are the same number, you're just asking what's the GCD of a number with itself. And that's always the number itself. In short, duplicates aren't a special case. The formula handles them for free. If you blanked on math.gcd in an interview, this brute force works too. Count down from the smaller number and stop at the first value that divides both cleanly. It's a totally fair thing to say out loud first, then improve it. The downside is it's slower and it's more code to get wrong under pressure. Math.gcd runs in big O of log of the smaller number because each step shrinks things fast, roughly like binary search. Brute force is big O of the smaller number itself, since it might check every candidate on the way down. Both use no extra memory, but for large numbers, Euclid's approach wins by a mile. With only 2 elements, min and max still work fine, no special handling needed. If every number is identical, GCD of a number with itself is just that number. And when one number divides the other, like 2 and 10, the smaller one is simply the answer. I once wasted actual interview minutes hand-rolling a GCD loop before remembering the standard library, had it the whole time, never again. So find your min, find your max, and let math.gcd do the heavy lifting. Keep shipping. See you tomorrow.